Yeah, I can't use it. No, mine is red, white, red. I lost I feel like they wrote there's so many guys. $16.
Okay, we're gonna talk about first derivative test today. So I think this will feel the most straightforward out of the concepts that we've done. We're just gonna be using the derivative. We'll be creating a slope sine line. We kind of already been doing this because this is basically what we've been doing with particle motion, but now we're going to instead of a velocity sine line, it's going to be an f prime sine line. Instead of moving left and right on a number line for a particle, now we're just a positive velocity is now going to be considered as a positive slope. Negative velocity is now going down on the graph. So I think a lot of this will feel familiar since we've seen it with particle motion. Let's turn to page 14 in your packet. So we know a derivative function is going to tell us information about slope. So we're going to use that to help us figure out where the actual graph of f of x is going to, when it's going to rise, when is it going to fall, when is it going to have a slope 0. And based off of that, we're also going to be able to determine where the graph is going to be experiencing a hill or valley, which we call a relative max or relative min, relative maximum or relative minimum. So what does the derivative represent? Derivative is simply the slope of a tangent to the function, to the curve. Whenever the function is increasing, and we always read the graph from left to right. So we always read the graph from left to right. If the graph is rising, then we know that whenever it's rising, every point on that graph is going to be experiencing a positive slope, a derivative, a positive derivative value. Whenever the function is decreasing, whenever there's a negative slope, then I know that all my f prime values at those points will be less than 0, less negative value. Likewise, when f prime is greater than 0, my function is rising, increasing. Whenever f prime is less than 0, then f of x is decreasing. When f prime of x is equal to 0, that means I'm experiencing a 0 slope. That means my function is constant. It's either horizontal or changing direction. So these are all places where our graph is experiencing 0 slope. So I'm going to highlight those points there. Right, so this is a slope 0, that's a slope 0, and that's a slope 0. Right? Whenever we have a horizontal tangent. So not all slope zeros will be a relative max, relative min, as we can see, but we know that slope zeros are a good place to consider as candidates for relative max and relative min. So just like with particle motion, where I had to create a velocity sine line, instead of calling it velocity sine line, we're just going to call it f prime. So we're going to find f prime. We're going to set f prime equal to 0. We're going to find our critical points. We're going to populate our f prime sine line, and then we're going to choose values in each subinterval to plug into f prime in each of the subinterval values, and then indicate the intervals as positive or negative. Positive would mean the graph is rising. Negative would mean that the graph is falling. Okay. So let's just move directly into example 1, and I think the steps will feel familiar. All right, example 1, determine the intervals in which the function is increasing and decreasing, and also locate relative extrema. So again, that just means find relative max and relative min. Okay, so let's start off with finding f prime. We can just rely on power rule to get to our derivative. Okay, bring down the 3. 3 times 1/3 becomes just 1. So bring down the 2. 6x becomes 6, and the 3 goes to us to a third. Okay, so I'm going to clean up f prime, and I'm also going to set f prime equal to 0. There's no denominator to worry about. If there were a denominator variable, then we would have to set that equal to 0 as well. Critical points through factoring, trinomial factoring. We can't move that 6 over and factor. We got to have that 0 if we want to go through factoring. Multiplies to be -6, adds up to be 5. Six and -1. Solve for x. Next up, we'll create our slope sign line, or with particle motion, we will call it velocity. Here, with this first derivative test, we're going to just call it f prime sign line, or our slope sign line. All right, choose values in each subinterval. Closest to 0, smaller the number, the easier it is to plug in usually. These numbers we're not going to use for anything else except to test whether it's positive or negative. So once we use these numbers, we're going to cross them out because we don't want to let those numbers interfere with our interval that we're going to state later. Okay. All right, where do we plug these -7, 0, and 2? I want slope behavior, so where do I plug into? F prime, yep. I want F prime. I want information about slope. So just like with the velocity sign line, you would plug it into the velocity to plug into their derivative. I like to plug into the factored form, less calculations that way. So I only care about gathering the signs here. So -7 plus 6 is negative. -7 minus 1 is negative. 2 negatives makes positive. So now I do want us to help us visualize what's happening here. So I would like for you guys to show an arrow indicating positive slope, just to kind of give you a visual how the graph is looking like. It's rising from left to right. Okay, 0 in for x, positive. 0 minus 1 is negative. Positive times negative is negative. Now I want you to draw an arrow indicating negative slope, that this portion of the graph is falling. All right, plug in 2. 2 plus 6 is positive. 2 minus 1 is positive. 2 positives makes positive. So the graph is rising, hits a slope 0 at x equals -6. It falls, hits a slope 0 at x equals 1, and then rises after that. Okay. Go ahead and cross off your -7, 0, 2. We're not going to use these numbers again, not in your intervals. They're just there to help us get our signs and our arrows. And after that, those numbers are not going to play a role. Now, the arrows I think are helpful because what do we expect at -6? Not only a slope 0, but there's a what? Relative what? Does that look like a relative max or relative min? Relative max, right? The graph is rising and then falls after that. So we know that it's going to hit a peak and it's going to go down. So there's going to be a hill at -6. Here, the graph is falling, followed by rising. So what do you expect here? Relative min. Yeah. So we're going to write out our intervals. So this is the way that you're going to write out your interval here. You're going to say f of x is increasing on the interval. So where's our function increasing? From where to where? What's this interval? Get -6. We're ignore that -7, right? And where else? 1 to infinity. Okay. We're also going to practice writing out our because statements. On your quiz and also on your test, you're going to have to write out justification. Justification is indicating with because statements why we're able to make that conclusion. Okay. Here it's because f prime is greater than 0. Make sure that you don't say words like it or graph. Those are not specific enough. You'll get points taken off on the test quiz as well as on the AP exam. They don't like those words. So make sure we specify what's happening, right? That f prime is greater than 0. Likewise, we can say f of x is decreasing on the interval from -6 to 1 because f prime of x is less than 0. Relative max at -6. If I wanted to find the full order pair for this relative maximum, where would I plug that -6 into? How would you find the y value at this point? The f prime or the f of x? F of x, yeah, f of x is location. So plug -6 back into the original if you want to find the ordered pair. And then your justification is because f prime changes from positive to negative. Okay, so we also have justification for relative max and relative min. There's a relative minimum at 1. If I want to find the full order pair, plug 1 into the original function. That'll give me my order pair, my x and my y value. And the justification is because f prime changes from negative to positive. Okay, let's practice writing all those down. So sometimes for your increase, decrease, your parentheses represent intervals. But for your relative max, relative min, these indicate order pairs. So I want to make sure that we understand that. I know we use the same notations for intervals and order pairs as well, but these mean different things, right? These are both x values, -6 to 1. But here, this relative max is x and y value. Okay, any questions? I do want to highlight a couple spots on the quiz. and test. So even though I would say justify with because statements, I think students tend to be pretty good about increase, decrease. But for some reason, maybe because it's an order pair, a lot of students want to leave these out. So just be sure that your because statements is not only for increase, decrease, but also for relative max and also for relative min. So I'm going to ask you for because statements for each of, it doesn't mean that every graph is going to experience increase, decrease, relative max, and relative min, right? The arrows and your sign line is going to help you determine that. It just so happens that this graph has all four properties, but for the properties that do exist on the graph, you do need to provide justification, all these because statements if I ask for it. Okay, next page. All right, example 2. Determine intervals in which the function is increasing and decreasing. Locate the relative extrema. So there is something that we do need to pay attention to. Does anything stand out to you about this function? You see any potential breaks in the graph? Denominator, right? So whatever causes the denominator to be 0 is going to be the what of the graph? Vertical asymptote. Yeah. So we know that there's a vertical asymptote at x equals 3. It may show up in our sign line. We may want to, okay, it depends on what the derivative gives us. But even if we know something is a vertical asymptote, but it shows up in our, as a critical point from our slope sign line, we still want to include that because even if we have a vertical asymptote, even if we know that a point has no chance of being a relative max, relative min, it still needs to have a place on your slope sign line because it does help separate your intervals of increase and decrease. Okay? But we already know, it's nice to know that, okay, there's a vertical asymptote at x equals 3. Even if the graph shows me a positive slope and negative slope on either side of 3, I'm never going to call this a relative max or relative min because I already know there's an asymptote there. Okay. So it's good to know that information. Now, we know that our slope sign line is going to come from f prime, but to get to f prime, look at how this function is set up. What rule do we have to go through if I want to find the derivative? Quotient rule. That's right. Yeah, we can't just say, oh, top's derivative is 5, denominator's derivative is 1, and be done with it. We got to go through a full quotient rule here. Okay. All right, so let's try that. Okay, we can't cancel the x minus 3's out, right? We got to spend the time to distribute the 5 through, combine like terms. Okay, here's my cleaned up f prime. Okay, so we got to find critical points. Where do we normally look for critical points? We have to consider what? Both the numerator and denominator, right? Is there anything from the numerator? No. All right, there's no variable here. If I try to set negative 17 equal to 0, that doesn't make sense. So at least we looked. We don't find anything. Moving on to the denominator, do we have a critical point from the denominator? Set that equal to 0, what do we get? X equals 3. Now, we know that x equals 3 is a vertical asymptote. It has no chance of being a relative max, relative min, but we still want to place it onto our sign line because we still need to indicate intervals of increase, decrease. So we already know this graph only has one critical point, and the one critical point is a vertical asymptote. There's no chance this graph is ever going to have a relative max, relative min, but we still need that separation at 3. Okay. Pick points on either side of 3. Plug into your f prime. Gather your slopes. Zero into my f prime, negative over a positive. Right, 0 minus 3, anything squared is going to be positive. Negative over positive is negative, so I know my graph is going to be falling. Plug 4 in, negative over a positive. Anything squared is still positive, so my graph is still falling. So the only behavior that I have here for this graph is what? Yeah, the graph is which of these 4 options here? Decreasing, yeah. And we definitely don't want to, we can't say, oh, these 2 are both negative. I'm going to merge it and say from negative to positivity. If there's any breaks, go ahead and separate those breaks. This one we have to break up. So make sure that, I think the safest thing to do, sometimes you can get away with merging the 2 behaviors and just skip over that critical point. But I think the safest thing to do is if you see a critical point, even if there's a shared behavior from both sides, go ahead and split up. Okay, that way you don't have to worry about. Oh wait, sometimes do I split up here? Do I not split up? If you always split up, you won't get points taken off because you didn't combine. Okay. So I would say if you see a critical point, but there's a shared slope on both sides, still split it up. Here you have to split up because of the asymptote. But if this was slope 0, you could merge together. I think splitting up is the easier decision. That way you can just repeat the same process every time. Okay, so we're going to do a bunch of practice problems here on page 16. And we're just going to go through first the written test. So you're going to practice finding f prime, creating your slope sign line, intervals of increase, decrease, writing out all your because statements. So let's start with 19 on page 16. I'll be right back. F prime is just negative 4x plus 4. Factor out to negative 4. Solve for x. I get negative 1. Choose 0 and 2 on both sides of 1. You get a positive slope followed by a negative slope. So we have a statement on increase, statement on decrease, and relative maximum. This is an order pair. I plug 1 back into the original function. I got a y value of 5. And notice relative max also has a because statement associated with it. Okay. Not just increase, decrease. All right, keep going. Let's look at 21. Okay, if you're ahead of me, just sometimes problems like 25 kind of throws us off because we're like, what do you do with that fraction? But remember, anytime my fractional value is just a number, I can always push it out in front as a coefficient and just force it to be part of power rule rather than, there's no need to go through quotient rule if my numerator or denominator is only showing a constant. Okay. After we find f prime, we can factor f6 out. Continue factoring, we get 1 and -2. Test -3, test 0, test 2 into your f prime. Our graph is showing positive slope, followed by negative slope, followed by positive slope. So all of our statements can make its way. We have statements about increasing, statements about decreasing. We have a relative maximum. And then that 20 I found from the original function. Relative minimum at -1, plug -1 to the original function to get that -7. Sorry, +1, plug 1 to the original function to get -7. And a note, because statements for everything that we write. Okay, 25. If I pull that out as 1/5, I can just distribute that 1/5 through. 1/5 x to the fifth minus 1/5 5x. That should be a setup for an easy power rule. There's no need for quotient. There's no need for product. Nothing, no need for chain. All we need is power rule if we can spend the time to clean up. ran out of room there, but we should be writing code statements as well. Increasing because f prime is greater than 0, decreasing because f prime is less than 0, relative max because f prime changes from positive to negative, relative min because f prime changes from a negative to a positive. Okay, try 27. Okay, so 27, We find f prime, clean that up. The only critical point we find is from the denominator. So we set that denominator to 0. We're going to get 0. Either side of 0, our slope is going to be positive because the squared is causing everything to be positive there. So increasing, make sure we do, I think it's safer to just always separate. Even if you see two of the same signs, go ahead and separate at that vertical point. Let's see if we can finish the last two here, 29 and 33. 29 is chain rule. 33, after we find f prime, we do want to spend the time to do common denominators so that we can get something clear to set equal to 0, both in the numerator and denominator. Okay, 29, we go through chain rule, outside derivative times inside derivative. Clean up your fraction. Set your numerator equal to 0 and denominator to 0. Nothing from the numerator. The denominator will give us -2. Test our sign lines. And once we have our sign line all filled out, then we can just read it off of our sign line, right? Increase, decrease, relative minimum. For 33, we do want to find the derivative, but I'm going to bring that x up to the top so I can just get both terms ready for power roll. Once I find my derivative, clean it back up, realize that my f prime was sitting as two separate terms here. So I want to get them to both show merge under the same fraction. So I need common denominator. My common denominator is going to be x squared. Balance each fraction. The one is missing in x squared, so multiply the top by x squared. This one has no changes. So now my merged fraction is 2x squared minus 1 over x squared. And now that our f prime is cleaned up, we can set both the numerator and denominator equal to 0. Find critical points, place all of our critical points onto our sign line, and then test each subvariable. Plus or minus 1 over 2 is same thing as root 2 over 2. So you don't have to rationalize the denominator. I did, but you don't have to. So I tested -1, I tested -1/2, 1/2, and 1. Okay, your calendar for homework, cross off 94 and 99 and no AP practice. Monday, we have one more topic to go over. We should be able to begin our quiz review. Tuesday is CSHD day, so no, Wednesday we'll do quiz review, and then Thursday. All right, go get your phones.